You're going to go ahead and open up the link for Physics Classroom. Make sure you use the bottom arrow here and open it in Safari. I think it just works better when you do that. This is called Name That Charge. So I'm going to go ahead and open it full screen, put in my name, and hit start. So the goal of this activity is to predict the type of charge processed by an object as the result of the charging process. So there's going to be different situations that they give you. If you miss one, you'll get another one. And don't forget you can use the help button on the bottom to get information. So rather than just guessing, I want you to actually go to the help button so that it'll teach you a little bit as to why you got something incorrect. Okay, let's try one or two of them together. A negatively charged foam board is on the table. A neutral aluminum pie tin is held above it. The pie tin is then touched. So let's look. You've got negatives, you've got a pie tin, and then it goes away. When the process is over, what is the charge on the foam board? So let's watch it again. When you bring the pie tin close, before the other hand touches the pie tin, what happens is, since you've got negatives there on the bottom, the negatives in the pie tin are going to want to run away. They're going to want to get further and further away from that charged foam board. So you're going to have positives closer to the bottom of the pie tin and negatives closer to the top of the pie tin. And then when the hand touches the pie tin, it grounds the tin, so it allows those electrons to leave, which leaves the tin positive. So what is the charge on the foam board afterwards? Well, that doesn't change. And what is the charge on the pie tin afterward? It's going to be positive. So let's go ahead and check. And I got that one right. Woohoo! That was a really hard one because that's charging by induction. Let's try a couple more and see how we do. A glass plate is rubbed with a cotton cloth. Cotton has a greater affinity for electrons than glass. That means that cotton wants to take electrons. So let's watch. So we want to know, what is the charge on the glass plate? So again, a glass plate is rubbed with a cotton cloth. Cotton has a greater affinity for electrons than glass. So that means the glass is going to give up its electrons to the cotton. A greater affinity means it wants to take electrons. So the charge on the cotton is going to be negative because it wants to take electrons. It's going to end up with more, which means we left the glass with less electrons. And if I'm missing electrons, that means I have too many positives and not enough negatives to balance it out. So the charge on the glass plate is going to be positive. Let's go ahead and check that out. And we got that one right. Awesome. Let's try one more. A neutral aluminum pie tin is brought near and touched to a negatively charged Van de Graaff generator. So let's look at what happens here. All right, what is the charge after it's touched? What is the charge on the pie tin? It's going to be negative because those negative charges are going to spread out from the Van de Graaff generator into that pie tin. The pie tin is a very good conductor. What is the charge on the Van de Graaff generator? Well, it just stays negative. Those charges just spread out. Okay, hopefully that's a good start for you. Go ahead and work your way through, and remember that if you are having trouble, please check on the little help me button down here. I'm going to press it now so that you can see what happens when you press